Hello, welcome to Chapter 7. In Chapter 7, we're going to learn about many different types of, or a few different types of functions, I should say. Uh, Today we're going to get an introduction to logarithms before we really get into functions. So, before we get into logarithms, we have to talk about powers. I want everybody to know they're 2 to the 8th power. So that's 2, 4, 8, 16, 32, 64, 128, and 256. I will assume that everybody can do these without a calculator. Your powers of 3, I'll assume you know up to 4. So that's 3, 9, 27, and 81. Your perfect squares, you should know 1 through 15. And 1 through 10, everybody should know without any question. Usually when I say that, I make a mistake writing them down. Now 11 is 121, 12 is 144. People generally get those. A lot of people get 169, but then they stop here. 14 is 196, and 15 is 225. Now your perfect cubes, all I expect you to have memorized is 1 through 5. So that's 1, 8, 27, 64, and 125. Now your laws of exponents. Anything to the 0 power is 1. A to the negative 1 just means 1 over a. And likewise, a to the negative n means 1 over a to the n. So, example, 3 to the negative 4th is 1 over 3 to the 4th, which is 1 over 81. If I have a fraction to a negative 1 exponent, that just flips the fraction. If I have a to the 1 over n, that means the nth root of a. So 9 to the 1/2 just means the square root of 9, which is 3. A to the m over n, m becomes the power and n is the root. Now when we're multiplying two variables with the same base, we add the exponents. If I take an exponent to another exponent, you multiply those two exponents. If I divide two bases that are the same with different exponents, I subtract m minus n. We can distribute the m to everything inside the parentheses, whether it looks like this or whether it looks like this. And that negative just flips over the fraction. So, just a little quiz here. 4 to the negative, or 2 to the negative 4 means 1 over 2 to the 4th, which is 1 over 16. 27 to the 1/3 means the third root of 27, which is 3, because 3 to the 3rd power is 27. 16 to the 3/4 means I take the 4th root of 16, and then I cube that. The 4th root of 16 is 2, so 2 cubed is 8. Now 2 to the negative 3 means 1 over 2 to the 3rd, which is 1/8. 25 to the 3/2 is the square root of 25 cubed. So that's going to be 5 cubed, which is 125. 27/8 to the negative 1/3. First thing that we can do is take the negative, so that flips the fraction over. And now it's just to the 1/3. Now 8 to the 1/3 is 2. 27 to the 1/3 is 3. Evaluate without a calculator. 4 to the 3rd, that's going to be 64. 4 times 4 times 4. That 4 is, we call the base. The 3 we call the exponent. 3 to the negative 2, that's 1 over 3 squared, which is 1/9. 64 to the 1/2, that means the square root of 64, which is 8. 27 to the 2/3, third root of 27 squared, which would be 3 squared, or 9. 8 to the negative 1/3. Uh, 8 to that negative is just going to be 1 over 8 to the 1/3. And now if I cube root both of these, it'll be 1/2. Alright, now if I want to find the inverse when I have y equals a to the x, the first thing you do is you switch the x and the y. So I have x equals a to the y. Now we have to solve for y. How do we solve for y? My person here is really thinking. Well, we have logarithms to the rescue. So how we solve for y is we can take the log, because the log base a of x is equal to y. Now the base is a, the exponent is y, and the x is what we call the argument. Now we can rewrite any exponential expression in logarithmic form. We can say log base 4 of 64 is equal to our exponent, which is 3. Log base 2 of our value over here is going to be our exponent, which is 7. Or log base 5 of 1/5 is negative 1. Or log base 49 of 7 is equal to 1/2. So this is how we write it in logarithmic form. So which of the following is in the logarithm form? 4 squared is equal to 16. Well, our base has to be 4, so log base 4. We take this number, 16, is equal to 2. So it looks log base 4 of 16 equals 2. So C is our correct answer. Now if we go in the opposite order, or same order, so we do log base 9 of 59,049 is equal to 5. I believe that's D. What is the base here? Hopefully everybody knows. 2 is the base. What is the argument? 2. Our x value is the argument, so that would be 8. And what would our exponent be? That's what we would be evaluating. So we're saying 2 to which power is equal to 8? Well, the answer has to be 3. 2 to the third power equals 8. So if we want to do these without a calculator, I'll say 10 to which power is equal to 10,000. Well, 10 squared is 100. 10 to the third power is 1,000. So it would be 10 to the fourth power here. So our answer for log base 10 of 10,000 is 4. One thing that's nice about 10 is we can just count up the zeros, and that's going to be our answer. Log base 2 of 32, we're saying 2 to which power is equal to 32? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So there were 5 2's I multiplied together. 2 times 2 is 4, 8, 16, 32. So 2 to the fifth will be 32. Log base 5 of 1, 5 to which power will equal 1? Oh, that has to be 0 power, because anything to the 0 power equals 1. So our answer here is 0. Try this one. Log base 3 of 81. 3 to which power equals 81? Well, 3 times 3 is 9, times 3 is 27, times 3, that equals 81. Since there's 4 of them, our answer is 4. Log base 8 of 64. 8 to which power is equal to 64? Well, 8 times 8 already gets us to 64, so there's only 2 of them, so that's our answer. Log base 10 of 1 million. Well, like I said before, we can just count up our zeros. Looks like there's 6, so 10 to the 6th must be a million. This one we have 5 to which power is equal to 125. 5 times 5 is 25, times 5 more is 125, so our answer is 3. 7 to which power is equal to 117,649. Now 7 times 7 is 49, times 7 more is 28, 343. Ooh, so we still got a ways to go. What we need to do is take out our calculator to do this, or this might take a long time. I bet what the answer is it's going to be 6, but multiply by 7 on your calculator, then multiply by 7 more, and then let's try multiplying by 7 more. So, oops. Since we know that equals 343, I know, let's see if this comes out to that number. So we have 9, 12, 10. This would be 16, 17, 12, 13. And then 3 is going to give us the same, 9, 2, 0, 1. So when I add these up, I'll get 9, 4, 6, 7, 1, 1, which is exactly what it was. So looks like the answer will be 6. Alright, now these get a little trickier. Log base 4 of 8. I'm saying 4 to which power is equal to 8. Now, some people might know the answer right off the bat. I think it's easier to put these both into the same base. 8 is 2 to the third power. 4 is 2 to the second power. So if 2 to the 2x is equal to 2 to the third power, 2x has to equal 3. So if I divide by 2 on both sides, x is going to be 3 halves. Now let's try this one. So this answer is 3 halves. 9 to the x power is going to equal 3. 9 is 3 to the second power. 3 is just 3 to the first power. So 2x has to equal 1. Now if I divide by 2 on both sides, my x value is 1 half. So log base 9 of 3 is 1 half, which makes sense because 9 to the 1 half is the square root of 9, and that equals 3. Alright, try this one on your own. 25 to the x power is equal to 125. So that's going to be 5 to the 2x equals 5 to the third power. So 2x is equal to 3. Divide by 2 on both sides, and x equals 3 halves. Now we'll have 2 to what power is equal to 1/16th? Well, we know 1/16th is going to be 2, or maybe I'll back up a step. 16 is 2 to the fourth power. So this is 2 to the negative 4. So if I have 2 to the x equals 2 to the negative 4, x has to equal negative 4. So if I have 64 to the x is equal to 1/16th. Looks like both of these could go down to 4. This is 4 to the 3, or 3x. This is equal to 4 to the negative 2. So 3x is equal to negative 2. Divide by 3 on both sides, and x is negative 2/3. Try this one. 3 to what power is equal to 1 over 81? Well, we know 81 is 3 times 3 times 3 times 3. So this is 3 to the negative 4th. So my x value is negative 4. Log base 64 of 16. 64 to the x power is equal to 16. So that's going to be 4 to the 3x is equal to 4 squared. So 3x is equal to 2. Divide by 3 on both sides, and x is equal to 2/3. All right, hopefully that's enough to get you through the homework. Good luck with it.